Today I want to speak about application of advanced information technologies and mathematical algorithms in the field of art analysis and architecture. The mathematics is the basic of all the sciences, the basic of information on the planet, and one of the most international language that we all speaks on a daily basis. There are mathematical principles lying between all and everything around us. Speaking the Galileo words, the book of nature is written in the language of mathematics. Today I want to speak about the following areas of mathematics in the field of art, the mathematical methods and algorithmization, augmented reality and virtual reality, data security and cryptography, indoor navigation, and gamification methods. And more of them I want to speak about blockchain. Speaking of mathematical methods, I want to start with an example from the Todd conference. The brain scientist describes the feeling when she got the stroke. The logical part of her brain stops functioning, and all she could see was the noise, a field of pixels. She spent 8 years learning from the beginning how to speak, interpret objects and interact with them. Same goes with the personal computer. Like our brain, computer could see pixels, memorize data, analyze it, break it into groups, and etc. The more methods, algorithms, and data it knows, the faster it could learn. So speaking about its parts, the computer vision and the computer vision algorithms, it is the way we could teach computer to analyze pixel noise. For example, we want to understand the principles which artists using while creating their art piece, the specific algorithm, and the data we put in the algorithm could get every little detail out of it. The linear algebra is the fundamental method to break data into groups and fields, connect them and analyze. Neural networks, we use it to allow computer to learn by itself, to learn by learning. And the mathematical physics is the fundamental part of mathematics. It could, using the data, it could put every data into mathematical models. Okay. Sorry. It broke down. Okay. Speaking about augmented reality and virtual reality, we use geometry and topology to learn and get data from the world around us. We could engage more layers of data. For example, we could add text into picture, we could get a 3D model on a picture, and even we could put an application on the picture. The camera of the smartphone or every other camera could see the detail we want it to see and put the data on it. We could even, in the application like this, we developed it, we could understand what pictures are around us, we could see information about it, and even we could buy it if it's on sale. The main principles and the achievements of augmented and virtual reality is the communication. We could easily communicate with other people on the other layers of data. Somebody could communicate on the vision level, some on the text level. We could collaborate using it, and we could visualize more data using it. And speaking about our projects, we developed a tool for the animation studio Smishariki that allows animator, artists and producers use a pre-production tool more efficiently. Now they don't need long preparations with all the animations and stuff, communicate with other members of a big company and team. They just put on a virtual reality helmet and could walk around the scene, see it from the different angles, and could put specific objects on the scene to different places, and even create animations in that field. It now reduces the production time and cost of the cartoon for the Smishariki by 15 to 30%. The next thing is in indoor navigation. Indoor navigation is a pretty young sphere. We are using different approaches to that problem. The main idea is to get navigation into the building. There are a lot of problems because there is a lot of metal constructions, and the GPS data can't get into that space. So we used different approaches to solve that problem. First of all, a few years ago, we developed a navigation based on a Bluetooth hardware that was placed on the roof of the building under metal constructions. So we programmed hardware devices and the smartphone app for the navigation based on graphs. It solved it could get the mass of the point of the graph, and we are transferring from point to point under that Bluetooth hardware devices that was placed on a roof. But it was a very hard approach because of the mathematics line behind it. The mathematical model was pretty hard. The second method is recreating the 3D model of the room using optical data devices. Looking at it with a smartphone, we could determine the position in space. First of all, we look around with our smartphone, and the optical devices get the depth field of it. It recreates the 3D object of our room, and then we could navigate to it, looking at the different parts of that room and 3D model. The next thing I want to talk is gamification methods. Excuse me. It broke down again. Okay. Games are not just for kids. In fact, business across all the vertices that have nothing to do with gaming are using gamification methods to increase their conversion, inspire employers, generate buzz, and customer loyalty. At the end of the day, they increase their profit. Gamification is the application of game design methods and the basic game principles in not game context. And more people involved, the more data we could analyze. We'd analyze it with mathematical statistics and probability theory. The most popular gamification methods are prize and reward for social activity, engagement in the process, in the game process, and the competitive leaderboard. This system you see here was built for one of the biggest theme centers for children and their parents. It's called Kidzania. It was a navigation based on Bluetooth hardware and gamification methods where children get coins, and then they exchange their coins for prizes and rewards. Now I want to speak about blockchain. It is an emerging sphere. It is a distributed network for people communicating on a different layers. Blockchain is based on mathematics. It's called elliptic curve digital signature algorithm that using elliptic curves and elliptic cryptography. The elliptic, first of all, we are solving the problem where we're generating the elliptic curve. We then generate the elliptical field. We put all the points, keys, and then the key generation process going in. As an example, I want to state our startup project that is based on a blockchain. We are developing a service that could provide secure and crystal clearness on every point of art management, from museums to auction houses, from storing to selling the art. Every single move of the art is encrypted, and it is written on into a big distributed network. Our clients and partners are focused on different spheres of art, from museums to modern computer animation studios. Together we are solving a wide variety of today problems. The presentation was not mostly about the mathematics me and my colleagues know and love. It is more about the mathematics that we use and implement in all our solutions for the tomorrow problems. Thank you for your time.
Thank you. Any question? Thank you. У нас следующий доклад.
Next speaker.